Good evening, everyone, and welcome to the Understanding Behavior live stream. Today we are going over measurement part 2. If you haven't seen the first measurement yet, the video is in the description below, so check that out. Actually, if you're here watching it live, probably not yet. But anyway, it's on the channel. You can find it. It's a great intro. Today we're going to expand on that into our discontinuous measurements. Thank you so much. Yeah, thank you, Zamina. Good evening, all you beautiful people. If you're watching this post recording, thank you so much for clicking on this link. We've got a very fun presentation for you today. So like I said, measurement part 2. We're going to waste very little time. We're going to hop right into this. Okay, so last time in measurement part 1, we talked a little bit about how we pick measurement procedures. So it's based off of two main things: measurement validity. This is if the measurement captures a relevant dimension of the behavior that we're trying to change. And then also the ability of our data collector. So last time we talked a lot about our continuous measurements. A lot of these were valid options because they collect very thorough data about the behavior. But they're not always like the most user-friendly as far as the ability of our data collector, since they always require constant observation, and it requires that you really capture every instance of the behavior occurring. So we're going to focus a little bit more on this today. Can the data collector reasonably take accurate data given their other responsibilities? And when we talk about our discontinuous measurements, these allow for that a lot more easily, which is a nice advantage of them. Before we talk about our discontinuous measurements, though, we're going to finish up our continuous measurements by talking about our derivative measurements. So our derivative measurements, these are measurements that are derived from other measurements. So thinking about like derived information, for example, if I know like this girl is 50 inches tall and I know this boy is 52 inches tall, then I can derive that, yeah, he's taller than her. So using our information to pull out other information is what these measurements are looking at. We've got two main types of derivative measurements. Let's see in chat. Can you guys know these derivative measurements? Welcome, everyone. Brittany, it's good to see you here. Good to see some familiar faces. What do you guys think? Two different types of derivative measurements. I'll give you a clue. They're all multiple words long. One starts with a P, one starts with a T. Okay, cool. Yeah, Addie's got one. Zamina's got one. Trials to criterion. Cool. Yeah, Phasa's here. Great to see you. Percentage. Good. Awesome. So here are the two: trials to criterion and then percent of occurrence or percentage of occurrence. Excellent. If you haven't hit that like button yet, that would help so much. Would love to see that number go up. Let's first talk about percent of occurrence. So percent of occurrence is the number of times that a behavior occurs divided by the number of opportunities for the behavior. So that's what we're looking at, the occurrence. We're going to look at the number of behaviors occurred as our first number and then divided by the opportunities. As far as the utility for this, it seems a little bit simple, but it's like when the opportunity for the behavior is highly relevant to the behavior or measurement that we're trying to track. So we're all relating this back to our measurement validity. In some cases, a percent of occurrence is going to be a lot more useful than something like a frequency or rate alone. So let me give you an example of that. First of all, we have with accuracy. Let's talk about maybe a relatable example if you've taken the BCBA exam yet. What if I told you I got 175 questions right on the BCBA exam? Okay, well, that's pretty impressive. Like, it's only 185 on there total, and there's 10 that don't count. So that's pretty impressive. But now if I told you I took the BCBA exam 4 times, like, oh, that's a little bit different. So if I only took it 1 time, this would have been really great, 175 out of 175. But now that I took it 4 times, like, oh, 175 out of almost 800, that's like barely better than chance. So that's why what we mean when like the opportunity for the behavior is highly relevant. So if we look at an accuracy example, we would calculate that by the number of questions that you answer correctly divided by the number of questions that are given. So again, if like the 175 out of 175 is way more impressive than the 175 out of 800 or whatever. Let's look at this one. So if we were doing darts, what if I wanted to see like the percentage of bullseyes that I get? What are the two numbers that I would divide here? Let's see that in chat. So again, if we wanted to get percentage of bullseyes while I'm playing darts, how would I calculate that? What would I divide by what? Awesome, Zamina, I'm glad you like that example. That's great. Cool, I'm liking the answers in chat. Thank you, Brittany and Zamina, for responding. Cool, yeah, Faiza, thank you. Looks great. Love this. Yeah, Crystal, right on track. Faiza, I really like where you're going too. Brittany, right on track. This is great. So yeah, to get the percent of occurrence for bullseyes, I would take the number of bullseyes that I hit divided by the number of darts that I've thrown. So every time I throw a dart, that's an opportunity to get a bullseye. So again, we're taking the number of times the behavior occurred. So landed a shot that was a bullseye, divided by the number of opportunities for the behavior, which was every time that I threw a dart. Awesome, really nice. Thanks, chat. That was great. You guys are killing it. Let's talk a little bit about trials to criterion. So trials to criterion, kind of a tricky and weird measurement. So what this looks at is how many sessions or trials that it takes to meet a certain criteria. So what this really measures is the speed of skill acquisition. So if we have fewer trials to criterion, then we would know that the skill was acquired pretty quickly. But if we had more trials to criterion, then we would know that the skill would be acquired more slowly. So we could compare this across different individuals or even across different teaching methods. So here's a chart that I pulled from a Java article, and this has different trials to criterion. So let's look at this 30-minute schedule. Who had the slowest skill acquisition? Was it Jason, Scott, Steve, or Andrew? So looking at the trials to criterion, who had the slowest skills acquisition here? Cool, I'm liking it. Right on track. Great. Yeah, Brittany, Faiza, Zamina, Addie, all looks great here. So we would say Jason had the slowest skill acquisition because he had the longest trials to criterion to, they had the most trials to meet the criterion. Perfect. They also included this data point here, so mean trials per session, so how many times did they actually practice the skill per session. Kind of a useful, cool data point to add in there. And it shows that just like Andrew did more trials per day, and it didn't really seem that that affected the trials to criterion at all, but it was hard to say. Crystal's saying, my school has an e-commerce business and some of our students do different jobs within the business. We use trials as a criterion to determine how quickly they learn the TAs for each job. Yeah, I love that. That's really cool. So seeing like how many times how many exposures of training a particular skill it takes to actually learn the skill. That's a really cool measurement. Thanks for sharing that, Crystal. All right, cool. So let's go ahead and we're going to practice calculating our trials to criterion. So to calculate our trials to criterion, first we need to have our goal, and then we need to look at our data set. So we've got our data set here. So think about these as like different weeks, so Monday through Friday, and then it goes to the next week. So here is our goal. Johnny will imitate the model for 90% or more of opportunities for 3 consecutive sessions. So pretty basic, simple goal here. We have each of these sessions is going to just be one session. So in this one, we're actually going to look at the sessions to criterion. We're not necessarily going to look at like how many trials in each, but let's say assume that all of these were 10 trials. And when we even out that number, then we can look at the number of sessions as a totally appropriate thing to look at. So here's our goal. Check this out and then compare it to our data set. How many sessions did it take for Johnny to meet this goal criteria? All right, a lot of people saying 13. Let's see. Okay, so let's go ahead and look at our goal again. We want to get 90% for 3 or more consecutive sessions. So let's check it out. First week, really slow, no 90s. Over here, he's got 190, but this says consecutive sessions and his streak breaks right there. We see now in week 3, he's scoring very well. So 90, 100, 100. So we have 5, 10, 11, 12, 13 sessions to meet that criteria. Excellent. Really nice job in chat, everyone. So that's what you need is you always just need the goal, and then we need our data set. Look at this. If this asks for the trials to criterion instead of the sessions to criterion, it might say like something like each session there were 10 trials ran, and then we just multiply it by 10. So it would be 130 trials or 13 sessions to criterion. So this is a really useful measurement. Let's say like we were comparing different techniques for teaching imitation. So let's say we were using most to least with a prompter versus like naturalistic opportunity imitation. So if we compared those two methods for different targets and then compare the trials to criterion, then we can see which one is more effective, can teach the skills faster, and that will give us a data-informed decision of, yeah, we should use this procedure because the student learns faster when we use this procedure over this other procedure. So it can be a really useful tool and can give set up some really cool experiments to set up really efficient structures for your learners. Alrighty, so that is going to wrap up our continuous measurements. Remember, with our continuous measurements, we're collecting all of our relevant data. So even with like percent of occurrence, we're getting each occurrence of the behavior divided by each opportunity. Again, this requires constant observation. It gives us more complete data. But now we're going to talk about our discontinuous measurements. So these estimate our data through interval recording. Again, a really big advantage of these is that it eases the job for the trained data collector and then also creates measurement artifacts. So we'll talk about those when we dive into each of our different discontinuous measurement procedures. Before we talk about the different types, let's talk about some features that relate to all of our discontinuous measurement procedures. So in each of these, we're going to split up our session into equal intervals. There's not really a hard rule on how to do this, but essentially you want to make it doable for your data collector and short or long enough to provide useful information. The rule behind this is that the shorter the intervals that you do, the more accurate data you're going to have, or like less of an artifact, or another way to think about that is like it's going to more closely align to a continuous measurement. For our discontinuous measurements, we're going to mark each interval as either an occurrence or a non-occurrence. So usually this is indicated by either a plus or a minus. The amount of behavior that occurs in each interval is not really as relevant. So each of these different measurement procedures are going to have different criteria for counting as an occurrence or a non-occurrence, and that's really the only thing that we're going to be focusing on as far as our data. The data are reported as a % of occurrence. So luckily we just reviewed that. Actually, before I show that, what do you guys think we're going to divide to get the % of occurrence for our discontinuous measurements? What do you guys think? Let's see that in chat. Kind of extending what we're learning. It's always good to practice that so you have very generalizable skills. Yeah, the question again is, what do we divide to get the % of occurrence for any discontinuous measurement? So we need to take something divided by something for your answer. All right, yeah, I like where Crystal's going. Anybody else want to give that a shot? All right, well, shout out to Crystal. Did a really nice job there. And yeah, Brittany as well. Looks great. So this is going to be the number of intervals where the behavior occurred. So you can take the number of pluses that you have divided by the total number of intervals that you observe. So whether it was a plus or a minus, we're going to add those together, and then we'll divide these two. So again, that's going to get us our % of occurrence, number of times the behavior occurred, divided by the total number of opportunities for the behavior. In this case, each interval was an opportunity to get an occurrence or not. Excellent. With our partial interval recording, what we're going to do is we're going to mark an occurrence if the behavior occurs at any point of the interval. So like I discussed earlier, is that a lot of these discontinuous measurements create measurement artifacts. So that means a measurement artifact is essentially that the data are going to be represented in a certain way due to the way that it's recorded. So look at this. We mark an occurrence for an interval if it occurs at any point. So is that going to be likely to overestimate the behavior or underestimate the behavior? Oh, it looks like Brittany already knew what I was going to ask before I asked it. Right on track. Anybody else want to give that a go? And even cooler if you can explain why. Nothing wrong with that. I love an eager learner. Cool. Yeah, Zamina's got it too. Anybody want to try a rationale on this one? All right, so you guys are on track. It does tend to overestimate the behavior. Let's see what Brittany's got here. So the behavior can occur for 1 second and is counted for the entire interval. Excellent, I love that. So essentially showing like behavior occurs for a short time, but we mark the entire interval as an occurrence. A lot of people also like to hold on to the rule, it like overestimates duration but underestimates frequency. If that is a rule that you've been holding on to, just totally ditch it. Remember, when we're talking about interval recording and these discontinuous measurements, we're talking about units of time. So we can't directly compare units of time to number of times a behavior occurs. So those are actually just invalidly compared. So don't worry about that rule. Just think about it always overestimates behavior or overestimates the duration of the behavior, because that's what we're looking at. Well, I love all the people taking the challenge for the rationale here. Yeah, Danielle right on track. Good. Yeah, Crystal, love that. It looks great. Addie as well. Awesome. Love it, love it, love it. Way to go, crew. As far as the utility for this, so partial interval recording still requires constant observation. It does ease up the some space for the data collector a little bit, but you still need to constantly observe. You can pretty much use this for any problem behavior, again, as long as the person is able to constantly observe the individual. So usually you would want to do this for a one-on-one pairing or a behavior that's maybe less frequent. You can also use this for low rate skill acquisition behavior. So it still remains a valid measurement when you do this. So let's think about like kid never raises his hand to answer in questions in class. If that doesn't occur very often, then if we use partial interval recording, even if it was like a long interval, like 15 or 30 minutes or even an hour, we could still track if that behavior is increasing or not. So it can be a really useful tool for that as well. All right, we're going to go ahead and look at some data sets now. So what I have here is a table. We've got 10 different intervals in this table. Whenever there is a line, that is signaling that the behavior is occurring, and each of these boxes is going to be an interval. There are 10 intervals for each. Sorry, I meant to number these, but I slacked on that apparently. So what we're going to do is we're going to look at partial interval recording for each of these observations. We're going to look at observation 1 first. How many intervals would we mark as occurred with observation 1 using partial interval recording? All right, crowd is saying 5. Do we agree? The consensus seems to be accurate. Very nice. It looks like 5 intervals where the behavior occurred. Excellent job, everyone. Let's look at observation 2 now. How many intervals are we going to mark as an occurrence? All right. A lot of people saying 9. Zamina, Danielle, Brittany, Tina, and Faiza. All right, I would agree. So again, we're looking at any time in the interval where the behavior occurs. We see a little bit of the behavior in each of these except our final interval, so 9 of our 10. All right, how about our last one, observation 3? How many intervals would we mark for partial interval recording? All right, I'm liking the answers so far. Nevi looks good. Addie's got it. Danielle's got it. Great. So this one is going to be all 10. So each of these intervals, we see at least a little bit of behavior occurring. And again, look at the overestimation here. So this one's essentially saying like behavior is occurring 50% of the time. Like that line is not 50% of this whole box here. This one says 90% of the time. Still, like, that's a lot of behavior, but not 90%. So we're overestimating. This one says 100%, but we see big gaps without the behavior occurring. So overestimation on all 3 of these with our partial interval recording. Let's look at whole interval recording now. So instead of just occurring for a little bit, now we're looking at the behavior is occurring for the entire interval. So this will tend to underestimate behavior. I gave you guys the answer, but I want to see the explanation. So let's go ahead and in chat, tell me why whole interval recording might underestimate behavior. Why does it create that measurement artifact? Good, Zamina, I'm glad that exercise helped you. That's so great to hear. Glad you enjoyed it. We're popping now. We got 16 people here. While you guys are answering that, I forgot. I meant to give away this mock exam. I meant to do it earlier. But why don't we go ahead and give away a mock exam right now? While we have 16 lovely people here, the odds are in your favor. I'm going to pick a number 1 to 200. Let me actually get my number before you say anything. So don't give a number yet. You can give one number. Whoever is closest to my number is going to win the mock exam. Let's see that now in chat. I have my number. You can pick 1 to 200. Whoever is closest is going to win the mock exam. I've got my number. All right, let's see some of these answers in the meantime. So Brittany says this one underestimates the behavior because it must occur the whole time before it can be marked. So if it occurs for part of the interval in all 10, it would be 0. Yeah, really nice example. So I love how you like show like part of the interval, and that part of each interval would still be marked as a 0. It's a great example that emphasizes that. Crystal and Mark says no occurrence, even if the behavior occurs for most of the interval. Great explanation. Phasa, if the behavior did not occur for even 2 seconds of the interval, the whole interval is marked as non-occurrence. Yeah, excellent example there as well. Perfect. All right, last call. I think that's most people in chat here. Okay, I think we got our winner. So the number from the random number generator was 9. So that makes Jesse Base our winner. Congratulations. Send me an email and I will get you your free mock exam. So congratulations. Okay, let's keep trucking along. So with whole interval recording, our utility is that, again, this requires our constant observation. And then this is used for skill acquisition behavior, but skill acquisition behaviors that we want to occur continuously. So for example, this might be like participating in an activity, but it wouldn't be something like hand raising, because like we don't want hand raising to be occurring continuously. We only want we only want to track behaviors that we want to occur continuously. This might be like silent reading, activity participation, things like that. All right, exciting stuff. I love giving away free stuff. We're gonna go and now do the same exercise for whole interval recording. So let's look at observation 1. How many intervals am I gonna mark as an occurrence for observation 1 using whole interval recording? All right, a lot of people saying 0, and y'all would be absolutely correct. So we see this is kind of a short behavior. It's just like occurring for little blips of time. It does not occur for an entire interval anywhere. How about observation 2? How many intervals are we going to mark as an occurrence with whole interval recording for observation 2? Excellent. I'm liking the answers. Keep it up, chat. Good job, Annie, Zamina, Nevi, Crystal. Great. Perfect. This one is going to be 5. So let's count these out. We've got this one, 2, 3, 4, 5. This one kind of close, but we had that gap, so it doesn't count. All right, observation 3, whole interval recording. Let's go. Alrighty. Looking good, crew. Looking good. This one is going to be 4. Let's count these out. We've got this one counts 2, 3, and 4. So this does hit our whole interval. This one and this one, they were so close, but so close does not count with whole interval recording. Alrighty, let's talk about momentary time sampling. So this one, we're focusing on the end moment. That's just say momentary time sampling instead. So cool. All right, and this one we're gonna mark an occurrence if the behavior is occurring at the end of the interval. This one, it can either overestimate or underestimate. It doesn't really tend to do either of those, but it can go either way just depending on how the behavior pans out. As far as the utility for this, there's a lot of great utility for momentary time sampling. The biggest advantage is that this frees up a lot of time for our data collector. So since you only need to check in at the end moment instead of constantly observe your individual, that can free up tons of time and make data collection very easy. The only rule for momentary time sampling is that it cannot be used with short duration behavior, but it is flexible for either scale acquisition or behavior reduction targets. So only thing is that we can't use it with short duration behavior. And in observation 1 here, we have this short duration behavior, but how many intervals, if we're using momentary time sampling, would we mark as occurrence with observation 1? Yeah, Crystal mentioned that's great for observing more than one student as well. Absolutely. Since you only have to check in for a little bit, you can just do a quick scan and take our data very easily. Great. All right, so Brittany and Zamina are calling 0. I would agree with them. So what we're looking for is the behavior occurring at the end moment of the interval. We do not see that anywhere in this. And this is a short duration behavior. We said momentary time sampling in general is not good for short duration behaviors. So let's say like this behavior is punching, for example. That's a short duration behavior. So it's like a quick thing. So in this one, our kid punched, let's say 4, 5, 6, 7 times. Let's say these are like 30-second intervals each. Well, in 5 minutes, you just punched 7 times, and our data collection procedure didn't tell us. That's not cool. So this would make this a not very valid measurement for this behavior. But we saw partial interval was really great for this because it was sensitive to a lot of punching occurring, and it actually told us, yep, punching is occurring quite a bit. So this is a way more valid measurement for this behavior. All right, let's go ahead and look at observation 2 for momentary time sampling. What do we got here? All right, I'm liking the answers. Looking good, crew. Our answer here is going to be 8. Let's go ahead and count these out if you didn't see it. So we've got, we're looking at the end moments of the interval, so where that the 2 lines are overlapping. So we've got 1, 2, 3, 4, 5, 6, 7, 8. These last 2 do not have overlaps. Perfect. Let's look at observation 3 now. How many intervals are we going to mark as an occurrence? Alrighty. I'm liking it. So our last one here is going to be 9 intervals. Let's go ahead and count these out. So we've got 1, 2, not this one, 3, 4, 5, 6, 7, 8, 9. So it is occurring at that end of that final interval as well. Alrighty, well that is actually going to wrap up our presentation for discontinuous measurement. If you haven't seen yet, definitely check out the new BCBA exam, Beat the Beast teaching mock. I will drop a link to that in chat right now. And you can get $5 off that using the code UBStudy5, so definitely check that out. Let's see here. Yeah, we're gonna cut study hall a little early today. I just got back from vacation, so I'm a little tired. Usually I'd go a little bit longer and take some user topics. But I appreciate you all coming here so much. It's great to see you all again. Let me switch my screen here. I'm trying to find you guys the feedback form for today as well. Here it is. So I would love to get your feedback on how you guys are liking these the new version of the study halls where we do these little PowerPoints. Would love to get your input on that. So if you wouldn't mind filling out that form, would greatly appreciate it. There's also the link to the mock exam and the discount code in there as well. Perfect. Yeah, Brittany, the mock exam will not expire. You have as long as you need to take it. Yeah, I'm so glad that you guys enjoyed the presentation today. Thanks for coming. If you're watching later, thanks for watching. Appreciate you all. Hope you guys have a great week. We'll have new topic for next week. I don't know what it's going to be yet, but it is going to be something juicy. I promise you. We'll be a little bit more on top of the post for next week too. The mock exam is not timed. You can take as much time as you need for it as well. All right. Well, again, thank you guys so much for coming. Appreciate you. I will hope to see you next week.